All right. Now the last bit of review, last section that we're going to cover in this class is 0.4. We're going to talk about how to combine some functions. I am not going to spend a whole lot of time on this, maybe 20, 25 minutes or so. We're going to go kind of quick on it. I just want to make some key points, show you a few things that we can do, and that's it. Combining functions. Really what I need you to know is that we can add, subtract, multiply, divide, and compose functions. That's really about it. What we mean by add, subtract, multiply, divide, if I give you these two functions like f of x equals this, and g of x is this, you need to know how to add, subtract, multiply, and divide them. It's not hard, it's not a big deal. If we want f plus g of x, what that means is we're just going to simply add the functions together, f of x plus g of x. In our case, that means we'd have 1 plus square root of 2 minus x minus 2 plus x minus 3. You'd get rid of your parentheses by distributing if you had to, and then combine some like terms. In our case, we should be getting negative 2 plus square root of x minus 2 plus x. Can you verify that that's the right answer? Yeah? Yes, no? Okay. You should be able to do things like f minus g of x, which is basically the same thing, except you have a minus in the middle, you have to distribute a negative. You've been doing this stuff since basic algebra, which is why we're not going to spend a whole lot of time on it. In our case, we'd have 1 plus square root of x minus 2 minus x minus 3. Notice, though, this is just a little different than the addition. With the addition, you can just drop parentheses as there's no negative to distribute. However, what happens to these sides? Those are definitely going to change. You guys see that they're going to change. Yes, no? That's going to be minus x and then the plus 3. Do you see the plus 3? So our answer, you can verify this later on your own, this is going to be 4 plus square root of x minus 2 minus x. If you did f of x times g of x, that's the same thing, only you're going to have to distribute. So in our case, you get something like x plus x square root of x minus 2. Then you'd get minus 3 square root of x minus 2. And there's nothing you can do to combine that. That would be it. Maybe factor that back out, but I mean, you're doing circular mathematics, so that's it. The only other thing we can do with our basic operations is f over g of x. In this case, we just put one function over the other in the appropriate order and make sure we have a new domain restriction. In our case right here, you knew that x could not be equal to 3. Are you guys seeing the 3? Also, one note that I do need to make, when you're doing these functions and they're asking you to find the domain, I'll write this out for you. The domain is the intersection of the domains of the original functions. You can't ever get rid of domain problems. All you can do is make more of them. Let me give you one example of that so that you see what I'm talking about. Let's say that I had this and this, and I asked you for this. Firstly, give me a little head nod if you're okay on how all these came about. All right, that's pretty basic stuff. If you have the f times g of x, check this out. This would be the square root of x times the square root of x. Yes, no? How much is the square root of x times the square root of x? Okay. So the question is, what's the domain? Is it all real numbers? No. Is it all real numbers? It looks like it, doesn't it? It looks like, oh, I can plug all those things in. But the idea is, where did that come from? What functions did it come from? Can you plug in all numbers to this? Can you plug in all numbers to that? Can you plug in negatives to either of those? And the problem is, even though it looks like it, you can't plug in negatives here. Do you remember the idea with the whole? I introduced it to you a few days ago. I said, even though it looks like it was just x plus 2, looks like you should be able to plug in, or x minus 2, whatever it was, looks like you should be able to plug in 2. You couldn't, right? Because the domain came from the original function before you simplified it. The same thing happens here. Make this note. When you're looking for a domain, the domain is actually the intersection. Intersection is what numbers are common to both functions of the addition, subtraction, multiplication, or the division of those functions. So the domain is the intersection of the domains of the original functions. That's that symbol, that upside down U. Of the original functions. So for here, if you were asked to find the domain is not all real numbers. Heck no, even though it looks like it, the domain is not all real numbers. What the domain is numbers that are greater than or equal to 0. Why? Because that came from my original two functions. That's what those are coming from. How many people understand that? That you can't just look at the final answer and give me a better domain. I said this, it was actually kind of a key point from a few days ago. I said, you can't ever make a domain better. All you can do is make more problems. That's all you can do by combining functions. We can't change the domain of this. All we can do is make it worse by doing this, right? That made it worse. You actually have a bigger problem here with that 3. You can't fix domain problems. All you can do is make them worse somehow. That sucks, but it's true. Does that make sense to you? You can't ever fix it. All right. The last thing we're going to talk about, we can also compose functions. This will be the last thing that we do. Just make sure that you know how to do compositions. I'll go really quickly through this. This is an intermediate algebra concept, so I'm going to make sure that you know it. What we mean by compositions is if I have f of x equals like x to the third minus 4, and g of x is the square root of x. We're basically just substituting in one function for another. So these two things, unless they're inverses, will have different answers. If they are inverses, their answer will both be x. That's how you tell whether two functions are inverses or not. So f of g of x, I'll go through this one time. You make it f of g of x, or even said the same way. Then you start your substitution. You write f of, what is g of x? So we're going to write f of square root of x. What this says is you look at the function f. What's the function f right now? Read it out loud to me. X cubed minus 4. You all see that's x cubed minus 4? Let me kind of go back a little bit. I think I've lost some of you. What we're doing with compositions is inserting one function into another function. So how you start with it, the letters are in the same order here and here. F of g of x, f of g of x. Then we do a substitution. We actually do the composition. G of x becomes what g of x is. So g of x, we're writing square root of x. You with me on that? The only letter that's left that represents a function is the letter f. Agreed? So you go to that function. F says, what was it again? Everyone say it. Good. You say it again, you're x cubed minus 4. X cubed minus 4, you get it? Then everywhere you said x, replace that word with the word parentheses. So instead of x cubed minus 4, you're going to do parentheses cubed minus 4. Do you get that? And that's what you write. Okay. F was x cubed minus 4. I'm going to write parentheses cubed minus 4. Parentheses cubed minus 4. You okay with that so far? whatever was in this parentheses now goes in that parentheses. And that is your composition. That's as easy as that. Okay, we can do it that way for every composition you have. The other way, you would have g of f of x. That is g of, well, f of x is x cubed minus 4. The only letter that represents a function is g. I look at the g, it says square root of x. So I think square root of x, square root of x, square root of parentheses. Someone write square root of parentheses. Why? Because g said square root of parentheses right there. What goes in this parentheses? What goes in that parentheses? Whatever was in this one. Yeah. And that's how you do your composition. How many feel okay with the composition? That's a real fast way to do it. The last compositions that we need to talk about in the last 5 minutes or so. You should be able to do like multiple compositions as well. So for instance, if I say something crazy, like you got 3 functions, compose all of them, you should be able to do that. So let's say that we had like f's the square root of x. G is 1 over x. H is x cubed. Can you do they used to call them fog and goff, right? Can you do foggo? Haha. Can you do that one? F of G of H? What do you think? Yeah. Why don't you try it on your own and see if you come with the same thing I get? I'm going to spend about 30 seconds doing it. So see if you get it. And I'm going to do it real nice and slow up on the board. Okay, try it. Let's see. F of G of H of X. Oh my. Well, that's F of G of X cubed, because that's H of X. All right, I got that. Now I continue looking on the inside of my parentheses. G says 1 over X, true? So this says F of, G said 1 over X, that's 1 over parentheses. 1 over parentheses, that would be 1 over X cubed. You see where the X cubed is coming from? Okay. Now it's the only letter that represents a function left is F. So F says square root of X. So I'm going to say, okay, square root of X, that's square root of parentheses. Square root of parentheses is 1 over X cubed. Or if you want to be fancy about it, the square root of 1 is 1. X, that's to the 1/2 power, so that would be the square root of X cubed like this. Do you agree? And you can write that as well as 1 over X to the 3/2 power. Remember those fractional exponents, power over root? You could do that. Now if I ask you for this question, can you find F of G of H of 8? Can you do that? What's that mean to do? Yeah, it means find this, which you already did, right? You already have that on the board. Now can you plug in 8? Plug in 8, you're going to get 1 over 8 to the 3/2. By the way, the easy way to do these without a calculator, take, oh wait, did I give you the wrong one? No, I didn't, that's fine. I guess you would do it. Just plug in your calculator. What do you get out of that? To the 3/2. 1 over, is it a decimal? Okay, well, leave it 1 over 8 to the 3/2 for now. If it's something like a 4, you could have taken a square root and then cubed it. You would have gotten 1/8. The last thing we're going to talk about, oh, yeah, 30 seconds, perfect. You should be able to also go backwards. For instance, if I had given you something like h of x equals x minus 7 cubed, can you write that as a composition f of g of x? Can you write that as a composition? For instance, can you define the inside part as one function, the outside part as another function, and write it appropriately so that when you compose them, it gives you that? The answer is always yeah. You pick the inside part as a trivial function x, or I'm sorry, you pick the inside part as one function, and then you always have like x to the third. So for instance, in our case, I would say f of x would be x to the third. That's the outside part. Remember how we said parentheses to the, what x was parentheses? Whenever you see the parentheses, just treat that like an x. That's x to the third, and then g of x would be the inside part. And that would be your composition. So we should be able to go backwards as well. How many feel okay with what we talked about? Good deal. Right.